Hello everyone. This is the video of reactions of aldehyde and ketones part 2. This is a continuation of part 1. In part 2, I am going to explain enolate chemistry of carbonyl compounds. When a carbonyl compound contains alpha hydrogen, it undergoes ketoenol tautomerism spontaneously. Alpha hydrogen is acidic in nature due to presence of electron withdrawing carbonyl group. This is keto form and this is enol form. In the enol form, there is a C double bond C which is known as in and OH which is all. That's why it is called enol. Ketoenol tautomerism is not an example of resonance. It is an example of chemical equilibrium. And the equilibrium usually favors to keto form, but in some condition, enol form also favored. Now let's understand what is called enolate. Keto-enol tautomerism is a spontaneous process. Here we don't need to add any reagent. But when we want to generate enolate, we have to add some base like sodium hydroxide or potassium hydroxide. Now alpha hydrogen is acidic, so OH minus abstract the proton and a carbon ion generate. Now this negative charge moves to the carbon and this carbon oxygen double bond moves and we get this structure which is called enolate. Now what is the difference between the enol and enolate? Enol is a neutral molecule. Enolate is not neutral. It is a charged basis. And enol formation happens spontaneously. You don't need to add any kind of base, but enolate formation takes place only when we add some base like sodium hydroxide or potassium hydroxide in a carbonyl compound which contain alpha hydrogens. And in enolate, this CH2 minus act as a nucleophilic center. From the structure of enol and enolate, it is clear that enolate is more nucleophile than enol. And that's why enolate chemistry has lots of application in organic chemistry. One of the most useful reaction is aldol condensation reaction. In self-aldol condensation reaction, the carbonyl compound which contain alpha hydrogens in presence of base, it forms enolate. Enolate acts as a nucleophile because it has a carbon nucleophile. Now this carbon nucleophile attacks to the carbonyl carbon of another acetaldehyde and we get the product which is called aldol reaction product. The final step is where the OH and the hydrogen leaves as a water molecule and we get alpha beta unsaturated aldehyde. This is the aldol condensation product. In cross aldol condensation, we use two different types of carbonyl compound. Acetaldehyde contains alpha hydrogens and benzaldehyde does not contain any alpha hydrogen. So acetaldehyde will form enolate and benzaldehyde carbonyl carbon will act as a electrophile. The nucleophile attack to the carbonyl carbon of benzaldehyde and then we will be getting the alpha beta unsaturated aldehyde as a aldol condensation product. Thank you for watching this video, and if you like this video, share it with your friends and don't forget to subscribe my channel Chemistry Affinity.